Could you get 1.1 correct? No, so it's discrete because there's individual numbers. So does greater than or equal to matter now? Is there a difference between getting more than one right and more or greater than or equal to one right? Yeah, there's a big difference there. You're including one or not. So because it's discrete, this symbol is going to make a difference. So what would I choose? 5, choose more than one, which is what?
5, 4, 3,
2, 3, 4, or 5, right? So I could do 2, 5, choose 2, 0.2 to the second, failed 3 times, or 5, choose 3, times 0.2 to the third, times 0.8 to the second, or 5, choose 4, 5, choose 5. I'm not showing you the probability right now, and there's a reason to that, because I'm going to show you a shortcut here in just a second. Your calculator will be your definite friend here. Is that the only way to do this?
No.
Could you have done 1 and 0, and then subtracted it from 1 to get the 2, 3, 4, 5? Probably easier to just do 1 minus 5, choose 1, that's a 5, times 0.2 to the 1, 0.8 to the 4, plus 5, choose 0, times 0.2 to the 0, 0.8 to the 5. Either one of those would have worked. Either one of this or this. Do you understand the concept here? And the thinking? Take out the sheet I just gave you, the notes sheet. This should be almost word for word what you've got. Binomial distributions. What is the probability of getting 3 or more girls if a couple had 5 kids? We've been dealing with normal distributions, now we're getting into a binomial distribution where we can be specific and discrete. Whereas normal distribution is continuous because we got an infinite number of points under the bell curve, right? So this is the type of question you would get. What is the probability of getting 3 or more girls if a couple had 5 kids? Binomial setting is B instead of N. N comma P, where N is your number of trials. That hasn't changed, just like it was sample size before. P is your probability of success. There are 4 rules to a binomial setting. And this will be on the test. Number 1, and it should be the exact same thing. Number 1, test to make sure it's a binomial setting. To do that, you got to write out the 4 things, and this is what I'll be looking for, is these 4 things. Success, let's go back to the Spanish quiz. Success or failure on each question. Was there success or failure?
Yes.
You got it or you didn't. You got it wrong or you got it right. Was there a fixed number of observations? How many questions did you have on the quiz? 5, so there was a set number. No, were they independent? What you got on A, would it affect, or number 1, would it affect what you got on number 2? No, so they're independent, right, observations. And the probability of success is the same. Did I have 5 multiple choice for each one? Yes. So then I would have this, that's why you can use 0.2 for each one. Those 4 rules have to be true. When we get into geometric distribution next week, I think it's next week, or even Friday, Friday. When we get into geometric distribution, same rules except for one of them drops. Okay?
Now you said that that's what you're looking for. You're saying that on a test you want us to write it out so that we know that each one works, or just kind of know that's there?
No, you're going to have to. I'll have a question. Is this or prove this is a binomial setting?
Okay. So it'll say
1, success or failure. Yeah,
say
and you'll do a check. 3, fixed number of, yes, there were 10. Check.
Okay.
And observation. Each observation independent. Check. And you can abbreviate IND if you want. I would know what you mean. Probability of success, so P of S is the same. Check.
Okay.
And then you can kind of say what they are. I'm literally for you to write these 4 out, and I'll give you a space. That won't always be the case. They might just say, find the probability. And before you go and do it, you have to know that that has to be the first 4 things that you do.
So just kind of be looking for the wording, because like you said, it'll say prove. So.
Right.
Okay.
Now, binomial coefficient n, choose k. This is what we talked about the other day on the QOD. Is n factorial over k factorial times n minus k factorial? Don't worry about that. I mean, that's what it is, but we're going to be able to use NCR in our calculator. This gives the number of ways of arranging k successes among n observations. How many different ways can I arrange those trophies? How many different ways can I get 4 out of the 5 quiz questions right? Here's the equation that you need to know. Binomial probability, the probability that x equals k is n choose k times your probability of success. How many times? And then failure, which is 1 minus the probability of success. How many times? This rule right here is on your College Board sheet. So it's, you don't have to memorize. That one is on your College Board sheet. I think it's the 5th one down on the 2nd page. It says probability and then it gives you that equation. This is not, though, and you do need to know those 4 rules. Binomial setting. All right, so then let me go to this. This is where you want to learn the calculator, okay? 2 things, and this should be on your thing. It's about the middle of the front page. Binomial PDF versus binomial CDF. The way I remember the difference, there are 2 different ones. The way I remember the difference is PDF is particular, just like it's a P. It's a particular or an exact one. Whereas cumulative is C. Cumulative means to accumulate, to add up, right? That's how I remember, that's how I'll try and teach you, well, that's how I'm going to teach you to remember. Those words aren't exactly what they're doing, but that's the way to remember it, okay? You don't have to worry about that question right now. PDF versus CDF. So go to your calculator, go to second vars, which is distribution, because we're dealing with distributions, normal or binomial or geometric later. Binomial, so go down, scroll down or scroll up and go to binomial PDF or CDF. And it depends on your calculator, it's 0 or A, I think. You with me? So you're going to type in binomial PDF on your calculator. How many trials are there? What's the probability of success? And how many times do you succeed? Number of trials, probability of success, k successes. And I think I don't really spell out what N, P, and K are on your sheet, do I? Does it say? I don't think it does. So you might want to write it on there. N is number of trials, P is probability of success, K is your number of successes. Whereas if you're dealing with a binomial CDF, it's the same, N, P, K, but it finds from that number, which is what we call K, on down. Binomial CDF always finds from that number on down. So if I said 4 or less, you would do 4 or 3 or 2 or 1 or 0. It'll do 4 on down for you in a split second. And you'll have your answer, so you don't have to keep adding up. So this is binomial. Now here's the deal. On a test, you have to do the work and do plus, set up 2 of them and then do plus dot dot dot. Because once you set up 2, I can go, yep, you know what to do. And then you can do it on your calculator. Multiple choice, do a